Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about off-river or closed-loop pumped hydro. So let's dive right into it. Now, just a quick overview, we need this sort of technology. There is no option where we can survive without it. We need it because here's the deal. Reality is we have a scenario where people are doing solar farm on their own, not without a government subsidy because it's cost effective. So everybody wants to do it. Wind farm, cost effective. Everybody wants to do it. Here's the problem. None of these are reliable output sources. So fundamentally, we need a big ass battery. I mean, huge ass battery. Without it, don't even think about it. So what kind of scale we are talking about, what kind of numbers we are talking about. If you are saying anything smaller than gigawatt hour and megawatts of power, don't talk about it. That's the realistic reality of it. Flat out, we need very large batteries, like huge. And without it, we simply cannot go renewables. So that's the reality of it. And we are talking about battery outputs, not because just like, we need to figure out how the power output, because you may be surprised like how good we have become in last 10 years to predict what kind of power output will be from a wind generator. Like we are horrifyingly good. Like we can predict this, like this is a prediction for next month, this is the prediction for next few hours, and it matches up surprisingly horrifyingly accurately. It's like, yeah, and plus minus is barely few percent. It's like in single digit. We are that good now that if you're going to say this wind farm is going to produce 600 megawatt, it's going to produce 588 to 605. That's how good we are. So we got that part. It's not that it's unpredictable. Same goes for solar. Like we got it. We can figure it out. But because there is no buffer between the grid and the producers, we are stuck. So we need a big system to buffer that, and that will provide stability in the grid and 24/7 uptime. Without it, hope every household has giant ass battery. Otherwise, there is no logical way of doing this. Now, the first common thing you will think, chemical batteries, basically electrochemical solutions, be it lithium ion, be it lead acid, be it whatever have you. But reality is these things cannot scale up. No matter what you do, no matter how much you think, how much brute force you do, this sort of system does not scale up. Meaning the moment you start to talk about, let's say 50 gigawatt hour capacity, yeah, they will not work. Flat out, don't even think about it. So that's the reality of it. They do not scale up. They are very good for stabilization. Basically, that's what this picture is. This is from Australia system where this is a frequency response, and because of the battery's quick response, it's really good for that. It's like, I'm good, really great. And people will use this sort of technology to stabilize the grid in short duration. But when you are talking about long duration, as in like, let's say India goes all in on solar. Solar is far more cheaper compared to wind system. But again, it will take time for India to transition into offshore wind technology. But let's say we start to do that. You are talking about somehow to produce enough power in, let's say, 4 hours of a day to run the country overnight. Can we do that? Yes. We have enough surface area, that's taken care of. Problem is, where the hell you gonna store it? And that's when you talk about things that can store energy for 20 hours while dumping megawatts of it. At that point in time, this sort of chemical battery is like, no bro, nope, just no. And they do not even last. The best battery technology is metal hydrogen battery that is used in Hubble, that is used in basically International Space Station. Even they do not last for like, decades and decades. So fundamentally speaking, there is no alternate to simple old water battery. So deeper look into basically pumped hydro. It's one of those things that you will find very odd, is that it's a time-tested technology. Now you may be wondering why the heck we used to make pumped hydro when we always relied on coal as primary source of energy and hydro as primary source of energy. Why the heck we ever built pumped hydro back in the 50s, back in the 60s? Why the heck we did that? Well, reality was back in those days, people had a nuclear fever, so to say. So everybody went into this idea of that we're gonna use nuclear power in the future. While that did not came to be, but it did create a scenario where you had nuclear power output. Now that comes from a reactor. Now reactors have control system, but you inherently do not want to use them. You want the reactor to work 24/7. And given the fact the cost of building a reactor was so goddamn high, people are like, dude, that shall work it 24/7. So that creates a scenario you have constant output from the grid, meaning the producers are producing constant output. What the hell you do when demand goes down? You cannot send that power, that will literally blow up everything else. So what do? That time pumped hydro was created as a buffer solution, meaning it's gonna let the power plant run at constant output. Let's say this power plant is 2 gigawatt, 24/7, don't think too much about it. Pumped hydro is gonna store the energy, and when demand is there, it will dump energy into the grid to stabilize it. So that's why this sort of technology came to be that early on. Nuclear technology kind of mandated it, that it had to be there. That's why you will find many of these in Europe, many of these in USA that are very old. So that's the known technology. That's why we can say, yeah, it works, and we have tested this for decades. Then we come to another aspect that is very desirable, that it has power and capacity independent from each other. Because when you talk about, let's say, lithium ion system, you are limited by the cell. Like inherently that cell has a maximum capacity. You cannot exceed that, like unless you want to go boom with it. It also has maximum longevity, meaning at this sort of power output, let's say if you're cycling it at, let's say, 0.5 C, that will give you the most lifespan. Let's say this is the cell, this is the chemistry, it loves 0.5 C charging and discharging, and it's going to give you the longest life if you are running in that sort of scenario. That inherently limits your power and capacity. You cannot make it super huge because the output side will also become super huge. Now that may be desirable, may not be desirable. So having two independent system is far more desirable for grid operation, where you can be like, hey, I want something like, let's say India wants to just run on solar only. They are like, dude, solar is cost effective. We are making plants that can make solar self itself. We already have hundreds of plants that are making panels. We are only few steps away from making inverters. They're like, let's just go YOLO on solars. We need something that ludicrously high capacity but not ludicrously high power. You want these two things to be independent. Can't be realistically can't achieve that in lithium system, because again, each pack will have its own BMS, each pack will have its own battery, DC to AC converter. Inherently you will end up in a scenario, yeah, it is this many megawatt at this point. So having two vectors independent is desirable. So in the let's say in case of India, you could be like, hey, we don't have like really high power, but we have really long capacity, meaning normal scenario pumped hydro is generally 4 to 6 hours. Our could be like 20 hours capacity. That can be done. Now, how big we are talking about? We are talking some big numbers. How big we are talking about? Right now, China's largest pumped hydro is 3.6 gigawatt in terms of oomph that it has. That's like a 3.6 gigawatt power plant working without even thinking about it. And how much capacity it has? 40 gigawatt hour. Yeah, that's huge. And like second largest is in USA. That's also in similar ballpark. So we are talking some big capacity here. And that's why I specified. You will think, oh, lithium can, nah. Even you work your ass off, the best lithium ion you can build will not even come close to this. And price to performance ratio over the years, yeah, don't even think about this. Like just don't. So, and it also works for decades. All it requires is maintenance. You can't maintain a lithium ion cell. Once it has dendrite formation, it's self-destructing. You can't do anything to it. You can't, like, best you can do is like, yeah, recycle the whole thing, which is basically making the whole thing from ore. So that's why pumped hydro is one of those things that, thanks to nuclear technology we have created, thanks to experience and history, we can say, yeah, if you make this, it will work for decades. We know this, we have experience, and different continents have experience with this. It is one of those things that is awesome, large scale, works. Then what's the problem? Why don't we see it everywhere? Well, it has some side effects. Now that side effect is you require a goddamn dam on a river. So this dams have this lovely effects of creating ecological disaster. Now, if you are familiar with old, not even old school, like back in the days, people used to think dams are like amazing source of power because again, it does not require coal, it does not produce pollutions, but it destroys ecosystem, and ecosystem is directly, responsible for our food supply. So if you dam a river, it does not flood naturally. You literally create a scenario where you do not have enough sediment flow into the flood basin. That inherently means the soil that are not getting flooded is no longer becoming rich enough. So you end up in a scenario where literally bread basket becomes a dirt bucket. So ecological disaster, like China just brute force a Three Gorges Dam, but everybody who's studying it, even from satellite, that's how bad it is. Even from satellite, it's like, dude, this is just destroying. Let's not even talk about fishery. You are destroying the whole ecology behind and back of it, back of it and front of it. So it's fundamentally very destructive. And when you are trying to make pumped hydro, you have to figure out first a river that works 24/7 and into 365, then a place where you can make a dam, then you find a place where you still have enough place to make a height gradient, like, a reservoir on high places. Then the number of active places where you can actually do it goes down drastically. So you may think like, okay, how many places have river? Let's say you get 100 options. How many places have we can build an actual dam? Now the number of places is 50. How many places where we have reservoir plus a place where we can put a reservoir that is at least 100 meters up? Now the numbers are like 5 or 6. That's the problem with that. That's why we do not have enough location where we can do this on large scale. And it's very, very, very expensive. China can brute force whatever the heck they want because, like, again, their economy grew on literally pyramid scheme of, construction industry and, property industry. But that's not tangible for majority of the other countries, and not to mention public also opposes. Now in China they can poof you, but in India, even if they try to poof you, there is enough people is getting against you, yeah, even government will be scared of that. And same goes in USA. Again, some people will try to poof you, but if enough people get against you, you're gonna stop it. So inherently it becomes a dead thing for any country's politicians to, like, what, we're gonna force this. It's like, think of it this way, like, how the heck you gonna sell it? Yeah, we're gonna build a dam here, we're gonna flood this whole area, whoever living in this area be damned. That's a very weird thing to do. So realistically to me, it's not going to save the ecosystem or the environment. It's just going to change the damage type. Instead of CO2 damage, we are just directly damaging the organic ecosystem to it. So side effect just changes type if we go with this route. So that means there is no solution? Well, no. Thankfully, somebody figured out we don't need rivers for this. We can just close loop the damn thing. So if you decouple it from river or reservoir or lakes or whatever have you, you just have two ponds that have water that is going from A to B. That's it, done, go home. So that inherently isolates it from ecological disaster. Basically, there is no ecology because there is no ecology. It's just pond. Now, like ponds are ecology. No, no. Ponds are natural thing. In rainy seasons, especially in India, we have Sawan, which is like a monsoon season that lasts for around a month. We have random ponds popping up everywhere. It's a common thing. Nature knows how to deal with ponds. And if you do not put it anywhere where it's like, directly blocking the rivers, no problem. It's like from a nature's point of view, it's just a puddle of water from nature's point of view. So you're just making two goddamn big ponds. And how big ponds you want? Well, depending on how much capacity you want. That's why I said there are two vectors and both can be independently controlled. So in case of India, we may focus on a runtime. In case of Europe, they may focus on power. So in Europe case, if they can do it, they will try to find the reservoir height difference to be maximum. In case of India, we may be like, okay, generally it's classified if you do not go above 100 meters, it's not cost effective. So let's say 100 meters, but let's say there is a spot that is 300 meters, but does not have a place for reservoir. And India, there is another place that is 100 meters up, but only 100 meters up, but it has huge reservoir location. We'll choose that because that will give a run time. So these two vector controls your output system. So isolation from ecosystem, no more damage of ecosystem, and many sites can meet requirement. That's the interesting aspect. The moment you are just like, hey, where can we place two ponds? That's it. Now, there are some requirements also because you want this gradient to be as sharp as possible, meaning you want this to be as tall as possible. So if let's say, for example, 1,000 feet up and down, you do not want them to be very far apart because if you send it far apart, you can have any height you want, but inherently there is a ratio that you want to be inside. Generally, I said you do not want to be like, 1:10 ratio. So for every meter, 10 meter like this. So few kilometers, you do not want to be like hundreds of kilometers back and forth. So generally, you can make it sharper, the more efficient the system becomes. So now, even with that sort of strict requirement, many sites meet up the required system, and it's much quicker, cheaper to construct compared to the normal dam system. That's a normal dam that you have to build. Then you have to build a surplus structure to it. This is much faster. And some scenarios there are like natural water puddles already there. You can just extend it, and not to mention it does not have sediment issue that river dams have to deal with. So fundamentally, it's also longer lasting and much less maintenance requirement compared to a normal open loop system. So this is the technology that allows you to get benefits of pumped hydro without the side effect of ecological disasters. So what we can expect in the future? Well, reality is mathematically sitting down, like actually studying everything, there is nothing that even comes close to this sort of power. Yes, I have talked about cryogenic and air storage system, but again, it's a patented technology, meaning you have to go to that company, and if you're like, hey, what if I just clone it? You have to change it. You really do not want to piss off international community. It's like, yeah, we're just going to steal it. If you do that, again, bad things will happen to you. And trust me, China is going through that thing. So you do not want that. That creates a scenario where there are only few companies that can make this. You have to pay for them. And again, even if you can pay them, can they build it everywhere where you need to? There's a choke point, and inherently it does not even scale up to as much as you want. It has some advantages, but does not scale up very well. And this, on the other hand, scales up to ludicrous limit. You do not have to worry about, like, this is a very good example where you have a tiny solar farm. Now, again, like few megawatt capacity, and you have a small pumped hydro system, which is completely off loop, and then that's it. So basically, you can overbuild this farm. Let's say the requirement was government wanted 50 megawatt of solar farm. They're like, okay, we're gonna build 300 megawatt. Like, why? We're gonna give you 50 megawatt, 24/7. You're like, shut up and take my money. That's the whole point of this. You can have a giant ass farm. Of course, you have to account for inefficiencies and some rainy days. Then you build this reservoirs and you're done. So that's the whole point. And some designs are even better than this because they use sea, meaning, for example, if any place you have cliff, and sometimes you can be lucky enough where your cliff is like at least 100 meters deep, you just use the lower reservoir as the ocean, open ocean as your lower reservoir. So you don't even have to build lower reservoir, just a piping system. Japan did try to build this one, but it was very long ago, and because of the less requirement, they stopped it. But I think they are rebuilding it again. So some designs that can be used, and that will make it even cheaper. Now, it is expensive. Let's be very clear about it. It is expensive technology. Compared to lithium ion, it will take some time. But here's the deal. We know for a fact that this will work for a very long time. We know for a fact. And it is one of those systems that you can repair, like dam. It's something that you can build. You can repair it. You can replenish it, refurbish it. You can make sure this puppy lasts for decades and decades and decades. Because that's why you never talk about it like, oh, we built this Hoover Dam here. What the hell will happen in the future? No, it's not a battery. It's going to last as long as you're going to maintain it. So that's why. And some people have did very interesting math using satellite data. We have satellite with very good radars on them that get a very good height gradient map, and you can spot this many places. This is just a rough estimate which has all the height requirements and places where you can put reservoir. Now if you remove all the places which has population in there, remove that, remove places that does not have electrical connection, remove that, does not have roads, you still are left with enough places that you can take care of our energy requirement today. Yes, it will take 3 to 8 years to build. Yes, it will take some serious money, but it is something that you can put your money in without worrying about it. It's like, yeah, it's an expensive project, yeah, but it is something that Indian government knows how to deal with. Every country knows how to build dams, so that part is taken care of. We know this lasts for a very long time, so if it's not lasting, that means something is messed up. So you can figure it out, you can fix it, and even if your design is not very optimized, the Mark 1, Mark 2 will be better. So this is one of the technologies that you can truly trust for long duration without worrying about patents, without worrying about, like, where can we put this, and it does not have ecological disaster associated to it. So that's also an awesome plus. So we can truly scale our future to scale up as much as we want. We can have as much wind farm as we want. We can have as much solar farm as we want. Who knows, maybe even geothermal if you want. But by the way, if we can figure out geothermal, then we may not need geothermal. Can act as a throttable output. So geothermal will be the base load, and everything else would be like plus minus, and geothermal will be acting as a system. But again, that's in the future. So we can see very good potential in this, and China is really pushing into it. Like, they are building many systems for this, because it's a good technology to have. So this was my presentation on closed loop pumped hydro energy storage. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.